Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at part 1 of the guided notes on working with equations like their balances. You can follow along with me. It says in algebra we work with equations as if they are balances. The equal sign separates the one side of the equation from the other. And so this is what I mean by balances. You probably worked with these kind of things in science class. Some people call them scales. And you can see there's two sides to the balance. And the way the balances work is that if I, say, add 3 weights on the left side, I have to add 3 weights on the right side. If I don't, it won't stay balanced. If I would now take away one of those weights from the left side, then I have to take away 1 weight from the right side. Again, otherwise it won't stay balanced. If I double the amount that I'm going to put on the left, which would make the 3 weights turn into 6 weights, then I have to double the amount on the right side. Again, if I don't do that, then they won't stay balanced. And so we are going to be treating equations like they are balances, where the equal sign, which we always are going to see in an algebraic equation, or any kind of equation for that matter, the equal sign separates the left side from the right side. And in mathematics, in algebra, there are 4 properties that together pretty much all say the same thing. And what they say, you can follow along with me here, the addition, subtraction, multiplication, and division properties of equality. What they all say is that when you add, subtract, multiply, or divide each side of an equation by the same number, the 2 sides will remain equal. And what this means is that you can pretty much do whatever you want to one side of an equation as long as you do the same thing to the other side of the equation. It will keep the equation balanced. It will keep the equation remaining true. And so what I've done on your guided notes is I've taken an equation such as x plus 19 equals 306, okay? And I've decided to just totally randomly do whatever I wanted to on both sides. So here I added by 3 on the left side, and I added 3 by 3 on the right side. Notice I'm doing the same thing to both sides. And again, when I say both sides, what separates the left from the right side is the equal sign. And so it's almost like there's this invisible border going down through the equal sign, separating the left side from the right side. And so, as I just explained from this box, we can pretty much do whatever we want to an equation as long as we do the same thing to both sides, to the left side of the equal sign as we do to the right side of the equal sign. Now, what we're going to do, according to these directions, is we are just simply going to work down on both sides and get the results. That's all we're going to do. Our goal today is not to solve for the variable. We will be doing a lot of that in this chapter, solving for the variable. But right now, that's not our goal. My goal is just to get you used to working with equations like their balances, because it is something that's very different than what you did in elementary school. In elementary school, you always called the number to the right of the equation the answer. Guys, I need to stop getting you thinking that way. I need you to just look at an equation as if it is a balance. So that's really the goal of today's guided notes. So you can see I circled number 2. I'm going to do number 2 with you along with some other problems. And then after I'm done doing some problems with you, then you will try some on your own. So starting with number 2, we have the equal sign. Now we're always going to have an equal sign on these equations. So the first thing you need to do is find the equal sign, and then underneath the bar that goes straight across, just like an elementary school problem of adding 2 numbers together, you always had a bar underneath. We're going to find that equal sign, and we're going to keep it lined up directly underneath where it came from. So that's the very first thing you should do. Find the equal sign, bring it straight down, and write it. The equal sign should always stay lined up, okay? Now we're going to work down on both sides. So we're going to take negative 452, and we're going to add it by 31. This is the left side of the equation. Now, when you have a positive plus a negative, you'll subtract in your head 2 take away 1 is 1. 5 take away 3 is 2. Excuse me, 2. And then the 400 piece would stay 400, and this would stay negative because the negative 452 has the bigger absolute value. You are technically allowed to use a calculator for some of this stuff, but I would try to not use a calculator as much as possible. On the right-hand side of the equal sign, which used to have the expression n plus 21, we are now adding it by 31. Notice we're adding by 31 on both sides, and we're allowed to do that. That is the addition property of equality. You are allowed to add by the same thing on both sides, and it will keep the equation balanced. All right, so let's do that. 21 plus 31 would give us 52. But that n does not go away. That n is still there. Now, does the n get added by 31? No. We lined up the 31 underneath the 21 because they're like terms. 31 does not have an n, which is why I didn't line it up underneath the n. That n does not go away, so it needs to be brought straight down along with the addition sign, so the right-hand side of the equation gives us n plus 52. The left-hand side gave us negative 421. The equal sign is directly below where it used to be. This is how you work down whenever you do whatever you want to both sides of an equation. You just got to do the same thing to both sides. This is how you work down on both sides. All right, we're going to skip 1, 3, and 4 for now. You will eventually come back and do them. Let's do 5 and 6 together. So please find them on your page, 5 and 6. This is a little different, number 5. But it still has an equal sign, so find your equal sign, bring it straight down. So everybody do that right now. Write down the equal sign directly underneath where it came from, underneath this result bar. Now, notice what number 5 has. It has subtraction. So, pencils in your hand, make the subtracting by 3 become adding the opposite. Remember how subtraction is the same as adding the opposite? And technically, we are actually using the associative property on these problems. We're basically ignoring the first part, which is the W, and we're deciding to group the negative 3 with the other negative 3. That's technically the associative property, even though I'm not making you write parentheses. Here's the bottom line. Associative property does not work with subtraction. So this is why I need you to make subtraction become adding the opposite, because the associative property does work with addition. So bottom line, when you see subtraction on these problems, make it adding the opposite. All right. Let's work down. On the left side, we have W plus negative 3, and we are adding it by negative 3. So let's work down. Negative 3 plus negative 3 would give you negative 6. The W does not go away. Bring it straight down. So we have W plus negative 6. That's what you would get when you take W plus negative 3 and add it by negative 3. You get W plus negative 6. On the right-hand side, where we had negative 290. Again, we're adding that by negative 3. So that would give us negative plus negative. Add in your head. Answer stays negative. The only time two negatives make a positive is when you're multiplying or dividing. So when you add two negatives, you're going to get negative 293. And there you go. That's how you do problem number 5. Let's take a look at problem number 6. Now, unlike problem number 5, in between the variable and the number, we just have addition. Do not make addition become adding the opposite, all right? But notice what I've decided to do underneath on both sides. I've decided to subtract by 50s. Now, if you're like, Mr. Underkoffler, how do you know that's not just a negative 50? Well, then my question to you would be, what would I be doing with the negative 50? You can't just have them floating there. I'd have to be adding, subtracting, multiplying, or dividing. You would have to see a mathematical symbol, like adding, subtracting, multiplying, or dividing with the number that you do underneath the equation on both sides. So this is how I know this must be subtracting by 50 and not negative 50, because I have to be doing something mathematical underneath the equation on both sides, either adding, subtracting, multiplying, or dividing. That's why this must be me choosing to subtract by 50 underneath on both sides of the equation. Speaking of both sides, first thing you always do, find the equal sign. It separates the left side from the right side. Bring it straight down. Okay, since I am subtracting by 50 on both sides, and since I have taught you that you need to make subtraction become adding the opposite, pencils in your hand, make the first of the subtracting by 50s become adding the opposite, and do it on the other one as well. All right, now we can work down on both sides. On the left side, we have m plus 29, and we are adding it by negative 50. So the m is just going to stay as m, right? It's not being added by the negative 50 because they're not like terms. The 29 is being added by negative 50. When you have a positive plus a negative, you'll subtract in your head. The negative 50 has the bigger absolute value, so you will get negative 21. On the right-hand side, we had only the number 3, that was it, and we are adding it by negative 50. Again, positive plus negative, subtract in your head, you would get negative 47. Now, please remember, if you have subtraction, you must make it adding the opposite. Sometimes we have subtraction on the original equation, like number 5. There was subtraction in between the w and the 3. But on number 6, the subtraction was what we were doing to both sides with the subtracting by 50s. So that's why I made those become adding the opposite. So you have to be aware of where there might be subtraction on the equations and make them adding the opposite accordingly. All right, we're going to skip 7 and 8 for now. You will eventually do them on your own. Let's skip down to the bottom of the first page. Let's do number 10 together. Now, does number 10 have subtraction? No, it does not. How do I know it does not? Because there is nothing to the left of this dash to be subtracting the 72r from anything. That's how I know that that dash is a negative. And what does it mean when there is a number right next to a variable with nothing in between? That means the negative 72 is multiplied to the r. What have I decided to do on both sides? I have decided to divide by negative 8 on both sides. So there is no subtraction here to make adding the opposite. There is none. First thing you do, as I keep telling you, is find the equal sign, bring it straight down. All right, mine's a little off center there, but I had intended to bring this straight down. Keep your equal sign lined up because that's what separates the left side from the right side. Okay, if I have a negative 72r divided by negative 8, you do not need like terms to multiply or divide. That's something we've talked about before. The only time you need like terms is when you add or subtract. So I am allowed to take negative 72 with the r, and yes, that means times r, and I'm allowed to divide it by negative 8. So let's do that. Negative 72r divided by negative 8. A negative divided by a negative would give me a positive, so that'd be positive 9, and then the r would still be there. It doesn't disappear, so write it down. 9r is what we get on the left-hand side. Right-hand side, we have 40 divided by negative 8. We're working straight down. A positive divided by a negative is always a negative. It does not matter who has the bigger absolute value. And that would give me negative 5, because 40 divided by 8 is 5. So we're going to get negative 5. Okay, those are the problems that I wanted to guide you through. Now what I need you to do is I want you to finish up all the problems that we have currently skipped on the first page. So that would include 9, 11, and 12 that are right here at the bottom. It also includes 7 and 8, but also obviously 1, 3, and 4. So you might as well start with number 1, then 3 and 4. I want you to hit pause on the video. If you would like to kind of hit pause and maybe just do like 2 or 3 problems at a time, then hit play, and then, hit pause again and then do another 2 or 3 problems on your own, that's fine. If you would instead want to hit pause and do all of the, 7 or 8 problems that remain, that is also okay. So I will leave it up to you which way you want to do the pausing and the playing of this video. So hit pause, do these remaining problems on your own, then hit play when you're ready to see how you did. Okay, I hope you have already done 1, 3, and 4 on your own. Possibly you've done the others as well. If not, you'll be doing them soon. Let's see how you did. Problem number 1, did you find the equal sign? Did you bring it straight down? Left-hand side, the x will stay as x. It's not going to change. 19 plus 3 will give us 22. Right-hand side, 302 plus 3 is 305. Number 1 was kind of easy. There were no negatives. There was no subtraction to make adding the opposite. Basically, you just had to work straight down. adding by 3, which was not that hard to do. Problem number 3. Does number 3 have subtraction? No, it does not. Now, you might be like, Mr. Underkoffler, what about this dash next to the 2? It can't be subtraction because it's not what I'm doing to both sides, right? I'm adding by negative 56 on both sides, and it's to the left of an equal sign. You can't be subtracted from an equal sign. So this is how I know that that dash is a negative on the 2, not a subtraction symbol. So you should not have made that adding the opposite. If you accidentally did, please erase it. There is no subtraction on this problem. We're just going to work straight down. Now, first thing you should do, find the equal sign, bring it straight down. The r will stay as r. 56 plus negative 56, when you have a positive plus a negative, you will subtract in your head. This will give you 0, which is a little interesting. The right-hand side, negative 2 plus negative 56, you would add in your head. Answer stays negative. You add in your head because same signs as when you add. So this gives you negative 58. Now, this problem is unique. You could actually go further. What am I talking about? R plus 0. You can go further. You're like, what do you mean you can go further, Mr. Underkoffler? They're not like terms. Well, I know they're not like terms, but it's 0. Isn't it true that anything plus 0 is just itself? Like 5 plus 0 is 5. 20 plus 0 is 20. 1,000 plus 0 is 1,000. Well, then R plus 0 can become just R. Even though I have no clue what R actually happens to equal, well, actually, I will find out what it equals because the negative 58 is not going to change. So this is a little interesting. If you get a variable plus 0 after you've worked down on both sides, anything plus 0 is just itself. So that variable plus 0 becomes just the variable. And we accidentally, on number 3, found out what the R actually happened to equal, which is kind of interesting. Now, that cannot happen on number 1 or number 2. X plus 22, you can't do anything with that on number 1. They're not like terms. Don't you dare make that become 22x. That would be horribly wrong. You can't do anything with that. Number 2, n plus 52, you can't do anything with that. They're not like terms. You cannot add them together. But if you have a variable plus 0, then the additive identity property can kick in, and R plus 0 becomes R. All right, so that's a little something interesting on number 3. You might not have done that. Go ahead and write it down now and keep that in mind for the future. That's actually going to help you later on in this unit that we're doing. Problem number 4. Do we have subtraction anywhere? No, we do not. This is a negative sign to the left of the 13, so that's just a negative 13. That's not subtraction. All right, we find the equal sign. We bring it straight down. Make sure you did that. Keep your equal signs lined up. It appears I am adding by negative 45 on both sides. So negative 13 plus negative 45 would give you negative 58. And then bring down the plus a. It does not disappear. 45 plus negative 45 would be 0. Now, unlike number 3, this 0 can't go away. It's the only thing on the right-hand side of the equal sign. So it's got to stay. You can't keep a side of an equal sign with nothing on it. Okay, we got to keep that 0 there. It cannot go away. Moving on. Hopefully you did number 7 and 8 on your own. If you did not do 7 and 8 on your own yet, then please hit pause on the video now and do them at this time. Okay, I hope you gave yourself enough time to do 7 and 8, because I'm now going to go over them. Number 7, there is subtraction. Between the h and the negative 4 is a subtraction symbol. We need to make subtraction become adding the opposite, but this one is going to become adding a positive, because the opposite of negative 4 is a positive 4. Subtraction is the same as adding the opposite. So hopefully you did that. If you did not do that, then please pause the video and fix your errors. All right, where was I? The equal sign, we always bring it straight down. Now let's work on the left-hand side of the equal sign where we have negative 17 plus 5. That should give you negative 12. Positive plus negative, subtract in your head. Right-hand side, h is not going to change. It's still going to be h. 4 plus 5, that is a positive 4. We made subtraction adding the opposite. You have to do that before you could add by 5. Otherwise, you're trying to use the associative property with subtraction, and that would never, ever work. You have to make subtraction adding the opposite. So here we go. 4 plus 5 would give you 9. So we have h plus 9. Please fix any errors if you made errors. Number 8. Number 8 is kind of the meanest problem here from the first 8 problems because there is subtraction at 3 different places. Now, you'll notice I did not say that this dash that I'm highlighting in green is subtraction. It's not. It's a negative 29 because there's nothing to the left of it or above it that I could be subtracting it from. So that's how I know that that dash that I highlighted in green is a negative sign. But all of the other ones that I highlighted in yellow, they are subtracting. How do I know? I know it's subtracting by 34 because there is something to the left of it. So that's how I know this is C minus 34. I know that these are subtracting by 29s underneath the equation because, remember, underneath the equation, I am always either adding or subtracting or multiplying or dividing by something. So there always has to be a mathematical symbol with the number that stands for adding, subtracting, multiplying, or dividing. That's how I know that those dashes to the left of the 29s underneath the equation are subtraction symbols. So there is a lot of subtraction to make adding the opposite. Carefully watch the video. Did you make the minus 34 become plus negative? If not, pause the video and fix your mistakes. Did you make the minus 29 on the left become adding the opposite? If not, do it now. Did you make the minus 29 underneath the equation on the right-hand side become adding the opposite? If not, do it now. Please double check that you made all 3 places that had subtraction become adding the opposite. Okay, the equal sign, bring it straight down. The C does not change, it's still C. Negative 34 plus negative 29, I'm working on the left-hand side of the equal sign, will give me negative 63. The right-hand side, negative 29 plus negative 29 is negative 58. And that is working down on both sides for problem number 8. All right, moving on. Problem number 9. There is no subtraction on 9, 11, or 12. These are multiplication and division problems. So find the equal sign, bring it straight down. Left-hand side, 35W divided by 5. 35 divided by 5 is 7. And then keep the W on it. Please check. Make sure you have the W still there. 105 divided by 5 is 21. So that's number 9. Problem number 11, bring the equal sign straight down. Left-hand side, negative 63 divided by negative 9. A negative divided by a negative is a positive. So double check, make sure you have positive 7. Right-hand side of the equal sign, 18Q divided by negative 9 would give you negative 2Q. A positive divided by a negative is a negative. Again, fix your errors if you made any errors. Problem number 12, bring the equal sign straight down. Negative 12L, that's an L. The reason I make L lowercase cursive is because a printed L looks like a 1. So that's why I made that lowercase cursive. Negative 12L divided by negative 12, left-hand side. A negative divided by a negative is a positive. So I'm going to get positive 1L. Right-hand side, 48 divided by negative 12 gives me negative 4. Now, this is actually unique. That 1L means 1 times L. Don't we know that 1 times anything is just itself? 1 times 5 is 5. 1 times 20 is 20. 1 times 1,000 is 1,000. Well, then 1 times L is the same as just L. We can actually simplify that. The right-hand side is going to stay the way it was, negative 4. Bring it down. And so we just accidentally, on number 12, found the value of the variable L. It equals negative 4. You would not be able to do that on number 9, 10, or 11. 7W on number 9 cannot change. There's nothing you can do with that. Same with the 9 times R in number 10, or the negative 2 times Q in number 11. But if you have 1 times a variable, it is the same as just the variable. And that's why number 12 was able to go one further step. All right, that concludes part 1 and page 1 of the guided notes on working with equations like their balances. Please tune in for part 2. Thanks. We'll see you next time.